Welcome to another Too Tall Toby example done in IronCAD. This model is a 3D printed jig. Simple model to build. Let's go through this step by step in IronCAD, but we'll start off with the base, which has some values of 130, 40, and 80. Then we'll work on our extrusion here. It's got the cylinder as well. We'll show you how to build that and our cutouts as well. And then lastly, we'll finish this inside piece here. So we'll go ahead and show you how we're going to do this in IronCAD. We'll show you some tricks as well for building this section, whether you build it from scratch or if you want to do something that's reusable. We'll give you an idea on how to do that. So let's go ahead and hop over to IronCAD and we'll get started. So first we're going to start off again in 3D. We'll start off with the 3D extrude here. And again, we don't have to do any sketches. We can select down to our features and then drive our geometry to our base unit. So we've got an overall length of 130, our width is 80, and our height is 40. So the handles automatically toggle between each one of those to give us a quick way to input those values. And then we can just center our part here to start off with. So I'm currently, you can work in perspective or non-perspective, it's your choice. I'll just work in perspective in my case to show you that. But next we'll go ahead and work on our cutouts down here. And there's a couple of ways you can do this. You can start off with the cylinder, you can start off with the cut. Either way will work, but we'll start off with a cut cylinder, and I'm just going to do a through cut cylinder here. So I'm just going to go ahead and cut that all the way through. I'm just going to drop it anywhere on this edge because it really doesn't matter at the moment. So we're just going to drop it there, and we know the diameter for that is going to be 35 for that value. So we're going to start that off, and we know that this point here needs to have a certain distance from the edge of 23. So we can just turn on our tri-ball, move our tri-ball by hitting the space bar over to our point, and then we can simply just right click on our handle, say add a distance from point, and we'll select our point, and we know that needs to be 23. So we know that's the value there. And we're going to have to do another movement as well because this is not going to be on the center line here. It's going to be moved up, and I'm just going to show you how you can do that in IronCAD. So next, we'll go ahead and do our extrude cut. In this case, I don't want it to go all the way through because we want to cut halfway or a small section of this because there's just basically what it ends up with is a small segment inside of there. So what we'll do is we're going to drag and drop this extrude right onto the circular edge and hold the shift key down, and it's going to snap it to the center and put us right in the center here. And then we can just set our values, which we know this is 35 for the width, and we know our height on this value is 20. But right now, notice our bottom handle is down here, so we can simply just drag this up to the bottom to snap that. And now we can come to our top handle and set that value to be 20. So that's where the height of that value is. We know the depth of this is going to be, we know the overall of this is 80 minus 15 millimeters on total on the geometry. So we'll just take 40 minus 7.5, and that'll give us our value. So we'll just type in 40 minus 7.5, and that will give us our distance there. And we can just rotate it here just to show you this. I'm going to turn on the tri-ball, hit the space bar again. I'm just going to move it to a midpoint of an edge, and then I can just mirror it to the other side. So we can use mirror planes if you want, or a mirror tool to do that, but we use a tri-ball a lot to do this. So that gives us our basic shape, and this overall distance from here is going to be 15. If we measure that, if we want to, we can just select that face and hold our shift key down, select our other face, and it'll tell us down here it's 15 millimeters, and that's what we want. Now we know this whole cylinder is not at that location. So the center currently is here, but it needs to be snapped up to the top of that 20. So what we'll do is we'll select that hole, turn on our tri-ball again, and we're going to move it again one more time up to our quadrant point up at the top. And we'll just simply lock the axis and move it up to the top, and that will give us the location for that. But as you can see, the way we designed this, it'll actually extend down here and give us some extra geometry, which we don't want this extra geometry. We can just select down to the face level and it'll give us a handle. We can just pull it back, snap it to the other side here, just hold our shift key down, and that will cut that piece out and maintain our tangency. And we can do the same thing for the other side here. We'll just zoom in a little bit, select down to our face, pull that handle through, snap it over to the other edge, and it'll cut that through. So that's, again, we don't have to use any extrusions. We could have built this with extrudes, but that's just a fast way to do that particular shape. And that will give us, again, this end result still is going to be that 23 from there. Okay. So now that we have that cutout done, we'll go ahead and do some of the other geometry. One of those is this blend here on the edge. So we'll just select onto our edge, right click and say blend edges, and we know that value is a 20 millimeter radius. We'll type that in, hit enter twice, and that will apply that value and give that for us. And now we want to work on this backstage. So I'm going to show you a couple things here. I'm going to show you how to build this from scratch, and then I'll show you how to make it a little bit faster, because this is kind of a common shape to start off with, and I'll kind of show you how to do that. So anyways, I'm going to zoom here so I can see my extrusions, and what I'm going to do is drop my cylinder off onto this point to start off with, and we can pull this value however we want. We know it's actually going to be 50 millimeters on the inside here, so I can actually just select this handle here and add 50 to that, so it's going to be 100 to offset that, and the overall length actually is going to be 60 to get it in the right location. We know the diameter of this guy is actually 24 radius, so 48 for the diameter. And what we know from the positioning of this is actually the very top of this, so the quadrant to the bottom, we know the height of that. So what we'll do is, again, lock our tri-ball, hit the space bar to move it independently. We'll go up to the quadrant point, and then we can again do edit distance from point. We'll select that bottom location, it could be the edge of the point, either one, and we'll type in that value 115. So that'll put us in the right location for our shape. And now we can do the same thing for an extrude. We're just going to put that here again, and this time we're going to flip it to the other side in this case, and I'm going to align this to the bottom, and I'm going to right click these outside handles and align that with the shift key, snapping to the other side, and I can essentially just pull this up. Really doesn't matter too much where, because we're going to edit this cross section. So what we're going to do is right click on this and say edit the cross section. As you know, all of our features have sketches behind them, so you can actually go in and edit these, so we don't need this line here. We know we want to get tangent to this, so we're just going to project this guy up as a construction element up here. So now I have this here. I can just drag this over, and I can see that tangency showing there. And I can just do the same for the other side. Again, get that tangency there as well. And simply just draw a polyline to close that off, because that's going to be the final shape there at that tangency. You know, make sure if you forget to turn off your construction, you just select that line and turn it off there as well. So now that's basically gives us our closed shape, and we can hit finish. And we know the depth of this guy is 20 millimeters, so we can type that in. So that really is a simple way to build this. And just to give you an idea, there's other ways to do this. So one thing, you know, a lot of times we have these tangency values here. I'm just going to suppress these for a second. I'll show you another unique little trick here. So I've actually built a little custom profile here. So you can build your own profiles, drag them in, and put them in a catalog, so I can simply drag the shape out. And this one has some shapes. So we know that, for example, this is 80 for this thing here, so we can type in 80, and I've got this driving symmetrically. I can drop those out there and use this basically to build the same exact shape here. So we know, you know, what this value is here. We can do the math for this. I'm just going to drive it just to show you this. We'll just say 45 inside of here. If we wanted this to be a different value, 20, we just drive that profile. Then we can just simply right click on that. We want to create an extrude from that, so we can go into our create menu up here at the top, extrude, and we can extrude whatever value that you want. So we'll just say we'll add material and select our feature that we're going to add it to, hit OK. We can flip it. So basically you're just building another way and a faster way to do that, so you can reuse that geometry. Just I'm not at the right scale here, but I'm just showing you exactly how you could do this with building your own profiles and doing this thing. So then you can put your extra value for this out here and do the same thing for the other side as well there, and whatever value you needed for that. So if that needed to be 30 or whatever, you can do that. So that's another way to build that type of geometry, just kind of giving you guys ideas. You don't always have to start from scratch. You can, you know, if it's a common thing that you're doing with these tangent circles and things like that, you can build your profile and constraints and store it in catalog. You can store it as a feature if you like, drag it out as a feature and change those values, and you save you another step of extruding. So you can do features inside of here, profiles inside of here, assembly parts, animations, colors, all kinds of things in our catalogs. I just wanted to highlight as an example of something that you can do to help speed up your process. Again, one of the things we focus on is productivity, and that's just one example of what you can do there. So now that we have that added, we'll go ahead and add our last section here, which is going to be this last extrude piece here. Again, I'm just going to drag and drop on this point here, and again, I'm just going to right click, flip that direction. I'm going to line this up to the bottom edge here. I'm just holding the shift key to do that, and I can snap it to the inside here or just pull it in. It doesn't really matter at this point. And we know this side has an actual distance from the edge, so we can right click on that handle and say an edit distance from this outside edge, which they give us a dimension of 25. We can type that, and then I'm just going to simply align this back side because we know it's symmetrical. So I'm going to snap it to the back side, then right click to make it symmetrical, and we know that width is 15 inside of there. And we can pull this up. It doesn't really matter right now. We'll alter this here in the next step. So again, now that we extruded this in one direction, we can right click, add a cross section, and now we can do our modification. So we know this is where our point needs to be, and we just need to draw our circle that's tangent and coming to this point. So what we'll do is just simply draw a circle radius out here, and I know that radius needs to be 90 inside of there, so it's quite large inside of there. And you can put constraints on this if you like. You could have done it with a constraint inside of there and did it with a diameter or radius value. Either way, you can tie that. And we know we want to have a tangency for this, so we can select our circle and tangent to there to move it up. And now we need to make sure that this is lined with this edge. So what we can do is do this point vertical. Inside of here, so we want all these points to be vertical. We'll just select that point and our other point, and I'll move our cylinder over to that location. And that's basically that path that we need. And so the rest of this geometry is kind of, we don't need it anymore, so we can select it, delete that off. We can pull this up a little ways. Just as long as we're inside the geometry here, it doesn't really matter too much because it's in the middle of this. And we'll just pull this out some distance. And we can just simply trim off this stuff that we do not need. And that's our shape. And we can hit finish, and that will give us our final shape for that. And last, we can go to our IC Mech tools here. I'm going to drag and drop right on that center point, and we're going to put a hole on there. That's going to be a counterbore hole that has a diameter for the hole is 20, the counterbore is 30, and a depth of 7, and it's the through hole for this. So we'll just set those settings, hit OK. That'll apply that, and that will essentially build our model for us. So now we can just select on our part, go to our part properties, and we know this has a mass density of 1020 inside of there. We'll tab out of that. And that should give us a mass in grams at 517.126 or 1257, whichever how deep you go or how deep you go in your tolerances. But that's how you build this model, and just wanted to give you a few highlights along the way on how you could do this and how you can do some speed steps to make it faster by building your own custom catalog elements and using those, because that's a common one that's used, and you can just build it to meet your requirements, and it can be just variants of that as well if you want, different variations for those constraints and whatever, so you can reuse those whenever you need to help your design process. Hopefully you found this enjoyable, and we'll see you on the next one. Thank you very much.